Hi everyone. When a client gives you quantitative data to help them analyze it, it's usually in some form of a table with rows and columns, and you occasionally need to remove some of those columns. And this video will cover how to do that in R. Here are some reasons you might have for removing columns from your data set. One might be just to reduce the complexity. Sometimes the client may give you a file that has hundreds of columns, and eliminating the columns you don't need and aren't interested in is a nice way of sort of narrowing in the scope and not being confused by too many variables in the data set. Another reason you might want to remove a column is because you're removing an old version of a column. Let's say you have an age column, but you know that the client is only interested in looking at a few different categories for age. So once you create a new variable for age that reflects those categories, it may be easier to just remove the old column. Another reason I will often remove columns is to eliminate columns that identify the people in the data file. For example, you might want to remove social security number, date of birth, things like that, particularly if you need to then share that data file with somebody else, but you want to make sure that it doesn't contain those identifying columns. And if you want to follow along and replicate what I'm doing in this video, I'm using R version 4.1.2 and the dplyr package version 1.0.0. And if you don't know why that's important, then please look at the video I have on understanding R packages. So we'll start by putting the data into R. In this case, we're going to read a CSV file, and so we're going to use this read.csv function in the utils package, and then we're going to store that in this object that I'm going to call customer A data. So I'll highlight that, hit run. You'll see that the object is there, and R is storing this as a data frame. I can figure that out by typing in str parentheses and then typing in the name of the object, customer A data, and then I'll hit enter up here. And in this case, I'll see that there are 20 observations or 20 rows and 193 variables, and this is a data.frame. And a data frame is a type of object. It's a data type that R uses. It's the most common one that you'll be working with when you take data in SPSS, Excel, whatever, CSV, that sort of thing, and read it into R. And it's basically a table like you would view in Excel, and you can get a preview of that by clicking on the name of the object here. You won't be able to edit the files, but you'll be able to view them. And we will note again that there's 193 variables. So I chose this example, or came up with these data to give you a realistic example. Sometimes you may get a data file from a client that has a lot of variables, and you need to reduce down that number. And I created these data with a whole bunch of columns to give you a realistic example where you have a data file that has a lot of columns, and you don't necessarily need all of them, but you need to navigate your way around them, drop the ones that you don't care about, and keep the ones that you do. So because this is a data frame, one of the things we can do is we can type in the name of the data frame, in this case customer A data, and RStudio is nice enough to try to autocomplete, and then I can use this dollar sign, and this dollar sign allows me to identify a particular column within that data frame that we care about. And so let me pick education here. And if I just highlight that and run that, it'll give me all of the values for that column. And there are 20 rows, and so there are 20 values here for this column. So if you imagine it took the data set, plucked out the column called education, and because I requested that here and I ran it, it's just simply giving me all those values. And one easy way of deleting that column is to do this. So we take that and then we assign to that column the value of null, which will remove that column from the data frame. So you'll notice in advance there's 193 variables. If I highlight this and hit run, now there's 192. So it's eliminated that column. So that's a way that we can do that. If we click here, we'll notice that education was among these first few columns, and it's now no longer there. Now we could keep removing columns by copying this and then replacing the next one with like another column that we wanted to get rid of, like name. But that would be pretty tedious, especially if there are 193 columns in total and we're trying to eliminate a large number of them. So instead, there are a few other options. And one of the packages that's helpful for selecting columns and removing columns is the dplyr package. So again, if you haven't seen the Understanding R packages video, I encourage you to watch that. But I have already installed the dplyr package. And so now I'm going to use the library function to bring up that package. I'll type in dplyr. And once I run this, it'll allow me to use the functions that are within that dplyr package. And I know in advance that there are some functions that I want to use for selecting columns. And so the function that I want to use is actually called select. And so I type in the select function, and before that is the dplyr package : indicating that I want the select function from within the dplyr package. And one of the arguments that I'll give it is this data frame. And so I'm telling it that I want to, within this data frame, I want to select a certain set of columns. And here I'll just start listing off the columns. So let's say I want a data frame, a reduced data frame that only has ID, and in fact, just so I can see a preview of the columns that I'm working with, up here in the console, I'll just type in head, which will show me the first few records, and then customer A data, and I'll hit enter, and it shows me the first few rows, but then it wraps the columns, and there are a lot of columns here, so it just kind of keeps wrapping them. But let's say I'm only interested in ID and age and income. So I'll type in here ID, comma, age, comma, income. And let's save this as slim data. And so I'm going to take the result of this, which is going to be the selection of just the ID, age, and income column from the customer A data frame. And then I'm going to take that result and save it as slim data. So I'll highlight that and then run that. Now you see for slim data here, I have 20 observations, or 20 rows with 3 columns. So I click on that and you see that's exactly what I wanted. And that's great because I didn't have to drop, 190 columns. I was able to just select the 3 that I wanted. Now let's say I want the opposite. Let's say, I have 193 columns here, but I want all of them except for these 3. Okay, so another way I can do that is I can say, let me call this slightly slimmer, or slimmer data. And then I will copy this over. And now in this function, instead of indicating the names of these columns to indicate that I want them, I want it to take this customer A data, and then I want it to give me all of them except these columns. So I will put a minus sign in front of each of those. And this is shorthand for saying, I don't want these columns here. And so now, we see that at this point, customer A data has 192 columns, because if you recall, earlier up here, we didn't actually run the name one. We ran the education one, so it dropped education. And so at this point here, if I run this and assign it to slightly slimmer data, this should have 192 minus 3 columns. So 189 columns in the slightly slimmer data. And if I run that, we see that, yes, in fact, we have 189 columns here. And if I click on this, I should see that ID, age, and income are not present. And they're not. Now, let's say that what we want is actually a little bit more sophisticated. Let's click on this, and let's say we're looking at this and we go, okay, well, what I want is actually some of the columns are kind of spread throughout here. So I want to keep ID, and I'm just here making this up as an example. I want to keep ID. I don't care about name, but then I do want to keep age, income, credit score, and zip code. So ID, yes, no name, and then age through zip code. That's good. And then I also want to keep question 1 score through question 4 score. So let me talk that out. So I can use this select function. And let me just call this like custom data, just for lack of a better name. And then I said, oh, I want to keep ID. And I don't want name, but I want age through zip code. So I can type in age and then colon and then zip dot code. I think that's how it is. And R is case sensitive. So you need to type in the column in exactly the way that it's presented. So capital Z, lowercase ip dot, and then uppercase C, ODE. So I'm saying here age through zip code, and the way I'm identifying that is in this next chunk here, right after the comma, I'm saying age colon zip code, which means from age through zip code, capture all of those adjacent columns. And then I said, I also then want, I don't care about this stuff, I want question 1 score through question 4 score. So then I can do another column here, or comma, and then question 1 score, colon, question 4 score. Question 1 score, question 4 score. Okay, and now what I can do here is I'll run this, and you'll see that this custom data has 20 observations and 9 variables or columns. And look, it's got ID, age, income, credit score, zip code, which were all the columns that were next to one another here in this chunk of columns. And then next to that, question 1 score, question 2 score, question 3 score, and question 4 score. So this is a really nice way of sort of picking several variables that exist close to one another, and then also sprinkling in other columns that might not exist close to those other variables. And I want to drop a little plug for why you would even want to do this sort of thing in R. Now, if you're using a different program like Excel or SPSS, this might look ridiculous to you. You might be thinking, why, if I use one of these other programs, I can just click the column and hit delete. And then I can just, change individual values whenever I want. Just go in the cell, change it, and then hit save, and I'm good. But the problem is, let's say a customer comes back to you a couple weeks later and says, hey, these numbers are funny. Can you tell me what you did to get to these numbers? And you're left having to try to recall the steps that you took. And if you use R instead, you'd have all of this code, and you would see exactly what you did and exactly the order in which you did it, and you can recreate it identically. And so that's one of the huge benefits, particularly if you have lots of customers asking you to help them with their data analysis. If this video was useful and you want to learn more about how to use R for your clients' data analysis needs, please subscribe.